Hello and welcome friends in lecture 3 of module 1. In the last lecture we got introduced with traversing as one of the surveying techniques. We discussed that the method of traversing is very helpful in many ways and it can be categorized depending on the kind of equipment and methodology that we adopt. In this particular lecture, we'll be focusing on another two important surveying techniques, which are triangulation and trilateration. Here, we'll be discussing about what is the definition of these particular techniques, what are their types, their suitability, how it can be applied in the field conditions, how it can be classified, what are the various layouts of that particular triangulation networks and what is the respective selection criteria and the procedure that is expected to follow as far as that triangulation processes are concerned. So triangulation is a particular method in which the entire piece of the land that is to be surveyed is divided into number of triangles. Now here the basic thing is, why should we go for triangle as a figure, triangle as a basic figure of the triangulation network? It is well known and it is obvious that triangle is only geometrical figure which can be plotted by making use of simply its three sides. Even as we make use of the respective measures, either all three linear measures along with one angular measure, or otherwise all three angular measures along with just one length of the side of that particular triangle, we can compute the data related with that particular triangle that we are interested in. So here we are supposed to divide the entire terrain to be surveyed to be divided into this particular number of triangles. So say for example, as shown in this particular figure, the length AD is the line which is running centrally through the piece of the land that is to be surveyed. It serves as baseline on which the triangles are constructed so that the entire piece of the land that is under consideration can be surveyed. The way we discussed about the check line, tie line and choosing subsidiary stations, the same concepts are valid for this particular work also. So let's consider this particular triangle ABF, say. So here, as we have length AF measured as base length, and as we measure include angle A, include angle B, include angle F, here we can make use of sine rule. Say for example, A upon sine of A. So here this is side A. So A upon sine of A. B, which is nothing but the baseline here, upon sine of B should be equal to, say, F upon sine of F. As such, as we have length of this particular side in the form of this small b, as well as we have measured all these particular, say, include angles as A, B, F, hence all remaining sides can be worked out. So here as you see, this data AB as well as a BF is determined by making use of baseline and all equal angles. So having this particular BF with us, as we measure angle B, angle F, angle C, subsequently we will be able to measure all these particular sides of the triangle. In fact, we will be able to compute that particular sides of the triangle by making use of sine rule, and accordingly we can say proceed further. So here the way you see, in order to work out this particular say length df, one can follow the route through this particular network, through this particular network, or through this particular network. As such, here we can make use of number of checks on the computations that we'll be doing. Only the thing is that here the long range intervisibility is must. See, here the length of 15 km to 150 km is very common through the networks of surveying. Hence, here we have to go for this particular say concept of long range intervisibility. As such, the works are extensive, as huge areas are being covered, as refined equipment are used, skilled people are involved in such kind of the work, and the accuracy, precision required is very high. The work as such is very expensive. This particular technique can be suitable for any kind of surveying work. Say for example, we can think of some small area which is divided into number of triangles, and accordingly we can go for this triangulation work. Here, as you see, in fact, I request you to Google over these particular names. You will get huge information pertaining to triangulation geodetic works, and it's very interesting. Especially for India, you can make use of Wikipedia in order to collect some more information, some interesting information related with this particular triangulation network. So here just you can see this true geodetic arc. Arc is nothing but the distance, curvilinear distance rather, in between two stations which are having same longitude. So here some true geodetic arc was extending over these particular 10 countries. Here as you see, transcontinental arc, here it was covering around 2,700 surveying stations, and it was spread over 13,600 miles. It was covering some 44 states as the relevant information. So here the work is very interesting, but even lot many things are to be attended as far as this particular say triangulation network is concerned. Let's think about the various triangulation layouts that we can adopt. The way you see the various layouts, first one is simply single chain of the triangles. Here as you see, it is double chain of the triangles. Here as you see, it is nothing but braced quadrilaterals, and here this is showing some centered triangles in addition to centered polygons as such. So here first, that is single chain of the triangles, is suitable for narrow strip of the terrain. It is economical due to its simplicity. It is feasible for rapid works, but here the thing is, we can make use of just one route and multiple checks are not possible, which is nothing but the limitation of this particular work. Here, this particular network of the double triangles can be used where the land has got larger widths, and accordingly if we have to work in belt shaped terrain as such. Here the braced quadrilaterals are treated to be strongest and best possible arrangement as far as surveying network is concerned. Here, these particular networks can be constructed vertically as well as horizontally, intersecting each other, and accordingly, here huge area can be covered by making use of these particular brace quadrilaterals. Central triangles and polygons can be used when again vast area in all direction is to be covered. While adopting any of the triangle in order to form the triangulation network, again in turn, which is nothing but series of triangles, we have to go for well-conditioned triangle. Here, in order to understand the condition of this particular well-conditioned triangle, we have to simultaneously think about plotting of a particular station. So say if we wish to plot this particular apex by making use of these particular linear dimensions, we should see that their intersection of these particular sides will be so accurate that it will be giving precise position of that particular apex. Preferably, we should see that these two sides should be equal so that the angles that we have used in order to compute this particular side should also be equal. As such, here the way we see both these particular angles, include angles being equal, we should go for isosceles triangle. Smaller the angle that we measure, as we are involving sine rule, larger error will be reflected on the computation of the opposite side. Hence, we have to go for highest possible include angle. For triangle, it can be 90 degrees, but all the angles cannot be 90 degrees as far as the surveying triangulation network is concerned. Hence, we can go for some triangle which is equilateral in nature. So here, the best possible triangle that we can make use of is nothing but the equilateral triangle. But here, usually we prefer isosceles triangles, in which here the included angle at the best length are each of 56 degrees 14 minutes each. So here practically to have this kind of equilateral triangle or isosceles triangle is not possible. But as we discussed about the basic concepts related with the selection of the station in our earlier presentation, we saw that each of the angles that are defined by the various survey lines should not be too acute or too obtuse. So here, any triangle in which the included angle is having less than 30 degrees or more than 120 degrees should not be considered in order to form it as the part of triangulation network. So any triangle which does not have its included angle less than 30 degrees or more than 120 degrees will be treated as well-conditioned triangle as far as surveying network is concerned. So here various criteria can be considered as far as selection of the layout is concerned. As such, simple triangles should be preferably equilateral. Best quadrilaterals should preferably approximate squares. Centered polygons should be regular one. The arrangement should be such that the computations can be done through two or more independent routes. The arrangement should be such that at least one root and preferably two roots form well-conditioned triangles. No angle of the figure opposite a known side should be small, whichever end of the series is used for the computation. So here the background related with this particular say criteria already we have discussed about. Triangulation can be applied in number of senses. Here we discussed about traverse surveys that are mainly useful for establishing the horizontal control. However, it is further useful for to establishing accurate control for plane and geodetic surveys as well as to determine size and shape of the earth as well as to establish various stations for various engineering projects. The same terminology can also be extended for triangulation network also, but more about this we'll be discussing in our subsequent slides. So, here the classification of the triangulation can be done on the basis of the accuracy with which the length and direction of the survey line of the triangulation are determined. Triangulation systems of different accuracies depend on the extent and the purpose of the survey. Here, the classes of this particular triangulation can be considered under these three headings. One is first order or primary triangulation. Second one is secondary order or secondary triangulation. Third one is third order or tertiary triangulation. So here this particular first order or primary triangulation is highest order survey. So it is employed to determine the Earth's figure or shape or to furnish the most precise control network over which the secondary triangulation network can be connected. It embraces very huge area. Mostly here it is covering whole of the country. It is essential to take every precaution in order to make linear as well as angular measurements very precisely. Some general specification can be considered for this particular first order triangulation network. After carrying out the computations, it is expected to have the average triangular closure less than 1 second. Let me remind here, as we are dealing with this because of first order or primary triangulation, the kind of the triangle with which we will be dealing won't be plane one, it will be spherical triangle. That is, here the sum of each of that included angles won't be exactly 180 degrees, but it would be slightly more than that because each of the included angles will be spherical angle as such. Hence, here the spherical triangle closure and the included sum less than 1 second closure can be understood with the required emphasis. Even maximum triangular closure should not be more than 3 seconds. Here the baseline has to have length of 5 to 15 kilometers, whereas other sides could be 30 to 150 kilometers. While measuring the base, the permissible error is 1 in 3 lakh. The probable error of the base is expressed as 1 in 100,000. We can think of second order or secondary triangulation through this particular concept. It consists of number of the points fixed within the framework of the primary triangulation, the way we discussed on the previous slides. The stations are fixed at closer intervals. The size of the triangles are smaller as compared to what we adopt in the primary triangulation. The instruments and the methods that we use are not that precise, or the practices that we follow for this particular secondary triangulation won't be at par with the one that we adopt as far as preliminary network is concerned. Here, the average triangular closure is expected to be less than 3 seconds. Maximum triangular closure should not be more than 8 seconds. Length of the baseline could be 1.5 to 5 kilometers. Length of the sides, remaining sides, could be 8 to 65 kilometers, whereas actual error of the base is 1 in 150,000 and probable error of the base is 1 in 500,000. Third order or tertiary triangulation. It consists of number of the points fixed within the framework of secondary triangulation. It forms immediate control for the detailed engineering and other surveys. The size of the triangles are small as compared to what we adopt in preliminary as well as secondary network, and the instruments of certain moderate precision can also be used. Here, the general specification can be considered as average triangle closure is expected to be less than 6 seconds. Maximum triangle closure should not be more than 12 seconds. Length of the baseline could be 0.5 to 3 kilometers, whereas the remaining sides could be 1.5 to 10 kilometers. And actual error of the base is 1 in 750,000, whereas probable error of the base is 1 in 250,000. Let's consider about the steps that are involved in triangulation. The kind of the scope that we are discussing under this particular heading is related with geodetic surveys. So, here the kind of the work that is involved can be grouped under this particular, say, two headings. One is field work and another is office work. I hope you remember about the phases of the surveying that we discussed in our earlier phases, and here the discussion that we are trying to have goes with the same concepts. So, one must have carried out the reconnaissance related with these particular, say, surveys. So here the fieldwork, as you see, is divided into reconnaissance, selection of the triangulation stations, marking of the triangulation stations, selection of the sites for baseline measurement, and these things already we have discussed. One of the important concept is related with erection of the signals and towers. As you understood through earlier slides, while dealing with this particular triangulation network, we could be dealing with length of 15 kilometers, or even we can be dealing with 150 kilometers. And when we were discussing about that particular baseline concepts, we thought that the indivisibility of the station and balanced nature of that particular triangle is very important. So, we have to have these stations indivisible. So, in order to make this particular station indivisible over the longer sides, as long as, say, 150 kilometers. Say, if it is expected to measure from A towards B, the station B should be elevated to some such a height so that it will be seen from certain structure erected over A. So, here what you see is example of signal and tower. Let's understand the concept. The signal is some device erected over the station, triangulation station, so that it would be seen from longer lengths. It could be luminous, non-luminous, or even opaque in nature. The way you see here, people are standing here, they are erected very huge structure, 30 to 40 meters high. In fact, here the height of tower as well as signal would be depending on the nature of the terrain that is lying in between to given stations, as well as the minimum distance or the clearance that is required over the terrain that is prevailing in between these two stations. So, signal is meant for devices along with the structure in order to make the station visible. Tower is meant for measuring the direction towards the signal under consideration. Tower comprises two independent structures. One is for setting the equipment, and the surrounding one will be made for the positioning of servers. So next thing involves is measurement of the baseline. Even the measurement of the baseline is very crucial task. In fact, earlier people used to use some wooden rods or steel rods which were standardized, and they were applying number of corrections to get the exact horizontal distance over the curvilinear distance that are measured. With the advent of EDM equipment, that is electronic distance measurement equipment, this task was made a bit easy. Similarly, measurement of the horizontal angles, some specialized transits were used in order to measure these angles. In addition, there was a requirement of some typical stations which are termed as Laplace station in order to have astronomical observation to determine the azimuth or survey line. I hope you remember about the bearing. We used to define the magnetic north direction, and for initial survey line, we expected to measure 4 bearing by making use of compass. Here, as we are dealing with geodetic surveying, we won't be dealing with the magnetic north, but we will be dealing with true north, and the bearing as such measured will be named as azimuth of that particular line. So here, some specially designed Laplace stations and even the sites and observation taken to some astronomical bodies like pulse star or even true meridians was essential as far as this particular framework is concerned. As the data is collected, there was a necessity to have the observed angles adjusted to compute the lengths of the sites, computes the latitude and the departures and azimuths of all sites, and computation of independent coordinates in order to plot that particular networks. So here, the triangulation as such, as we consider as part of geodetic survey, it is expected to have the field work as well as office work broadly through the concept I tried to discuss here. Trilateration is just opposite to triangulation network. To recall, in triangulation, we make use of one base length and 3 angular measures to work out the data pertaining to the other sides, and same are used to compute the data pertaining to the subsequent network of the triangles. In trilateration, we make use of one angle and 3 sides in order to compute the data related with the series of network of the triangles. So, here triangulation and trilateration system consists of network of the triangles in which all the angles and lengths are measured. Such combined system represent strongest network for creating the horizontal control. So, triangulation can be done, even the trilateration can be done, and it is also possible to combine triangulation with trilateration. Since triangulation and trilateration system covers very large area, the curvature of the earth has to be taken into account the way we considered earlier. These surveys therefore invariably geodetic in nature. Fieldwork procedures for the establishment of the triangulation stations are similar to the procedures that we adopted for triangulation. So, we discussed about the basic concepts associated with the triangulation and traversing. I hope the concepts are clear to you. In subsequent presentations, we'll discuss about precision and probable errors and also reliability of surveying measurements. Thanks for your attention. I wish you very happy learning. Bye till then. Thank you very much.